All right, welcome back. We are on to lesson 2 of unit 8, and there's only 3 lessons this unit, so it's a short one. So let's talk about triangles. Basic principles you know about triangles is every triangle, the interior angles add up to 180. And because of that, we can write an equation to solve. If I know 2, I can figure out the third. All right, so parts of a triangle, vertex are the corners. Interior angles are the inside angles. We just talked about that. A triangle is 3 sides, a 3-sided polygon. And a line segment is the edge. So XZ is an edge or a line segment, and you can put a little, if you were to label that XZ, put a little line over it, like this. All right. Now let's use that information that if I know 2 of the angles, DEF, 3 vertices, D we know is 62, F we know is 39. We do not know E, measure of angle E. That's what that little M means. Together, it's 180. Okay, I'm going to combine my like terms. 62 plus 39 is 101 plus E equals 180. One more step to solve this equation. I have to get rid of a positive 101 by taking it away. If I do 180 minus 101, I am desperately low in space here. E, the measure of angle E, equals 79 degrees. Remember, anytime you have angles, you need to have that angle or degree symbol. Now, how do we solve them if we're just given a ratio? So I know that my first angle and my second angle is 3 times bigger than my first, and then my third angle is 8 times bigger than my first. So how do I figure these out? So what we're going to do is, to help us, we need to figure out what it's being multiplied by. All right, once I know the multiplier, I can just apply it 1 times, 3 times, 6 times. So to help us algebraically, we're going to put an X. That's our multiplier. We don't know it yet, but we will find it out. 3X, 6X. So what this shows us is whatever this X is, I can multiply 1 by it, 3 by it, 6 by it. I can get my answer, 180. So like any equation, combine like terms, 1X, 3X, 6X is 10X. Undo multiplication with division, divide both sides by 10. I get 18 degrees is X. Now that's not the answer. It says what are the measure of the angles. So my first angle is 1 times 18. That's 18 degrees. 3 times 18 is 54 degrees. And then you notice here 3 and 6. 6 is double 3. So what I can do is do right here is double 54. 108. Now, make sure everything's good. If we did this right and we have our ratios right, my second angle is triple my first, and my third angle, I'm getting my numbers mixed up, is 6 times as much as that. Or we could look at it, it's double 3, but 6 times 18 is also 108. Add them up. 1854 is 6072 plus 108 is 180. We're good to go. Now, if you take a triangle and extend it, each of the sides, extend them out, the interior plus the exterior make a line, therefore they are 100 supplementary, or they add up to 180. So if I know the exterior, I can find the interior. If I know the interior, I can find the exterior. And this kind of goes back to that line and angle relationships lesson where we talked about the parallel lines, the transversal, what are all the numbers worth. If you know one, you can figure them all out. Very similar here. If you know a piece of the puzzle, you can figure out everything else. Looking at this chair, angle 4 is 102. So that's this angle here. What's angle 1? Angle 1 is interior to 4. Together, they're supplementary. So what we're going to do is we're going to do 180 minus 102 and get 78 degrees for angle 1. Okay? Easy way to figure it out without measuring. Lastly, we're going to talk about how to classify triangles. 2 ways to classify: by the angles and by the sides. The key with the angles is look, are there any obtuse or right angles in there? Because if there's one right angle, it's a right triangle. Because they have to add up to 190, you can't add up to 180. You can't have 2 90s. 2 90s already equals 180, and then you don't have any room for the third. If you have an obtuse angle, same thing. It's bigger than 90. You can only have one of them, therefore the other 2 are acute. Every triangle always has 2 acute angles in it. The question is, what's the third? So here the third is obtuse, so it's an obtuse triangle. A right, it's a right triangle. Acute, it's an acute triangle, because all 3 are acute. Now, by the sides, scalene, none of the sides are the same. Isosceles, two of the sides, that's what these little tick marks mean. And equilateral, all the sides are the same.